Okay, in the previous video, I started talking to you about how your circuit diagram depends on your project. So I'm going to pretend that I have made this object over here in SolidWorks, this little house that I've made. And I've made it in SolidWorks, and now I'm trying to figure out where my LED is going to go. So for my little Christmas ornament house, I want my LEDs to go here, here, and here in the corner. And I also want some yellow LEDs to go here. Oh, doesn't want to work. Give me one sec. I want some yellow LEDs over here, and over here. There are two types of circuits that I could do in this particular case. One of them would look like this. I would have a battery, and I would have a wire, a resistor, an LED, then another LED, and straight back into my battery, and two more times, just like that, right? One LED, another LED, back into the circuit. Resistor, LED, another LED, and back into the circuit. I know the circuit diagram looks very sloppy, but I'm not very good at drawing with my hands. Okay, so which LEDs are which? So this is going to be my yellow. This is going to be a yellow. And this is going to be yellow. And the other ones will be red. This one's going to be my red, and my red. Okay. So if I were to use this diagram and try and put that into my circuit, where would I put my wires? So I'm going to try and map it out right now. So I'm going to have my battery somewhere over here. Then I'm going to have a resistor. And then I'm going to go into my, well, I have my reds on the top, right, instead of my yellows, but it doesn't really matter. Then I'm going to have my red LED over here. Then back to my wire. Into my yellow LED. It's my yellow LED. And then back into the battery. I know it doesn't look very pretty, but it's the best I can do with the drawing tools that I have. So once I start drawing it, I can lay it out everywhere. I can lay out each of my branches like that. Okay, so I redrew my circuit because it looked like a mess. And you can see that I have yellows on top, and each branch goes through the lights like this. It looks a little messy, but it's still more or less understandable. Now, the thing you need to keep in mind, this is not the only circuit diagram you could possibly make in this particular case. You can make another type of circuit diagram. Let me show you what it is. Here's another circuit diagram that I could possibly use for this particular project. By the way, this circuit diagram is one of the most common diagrams people use for this project. But the reason I probably wouldn't want to use it in my house is because it's going to have too many wires, right? Because my house, my little Christmas ornament house, is a very small object. So depending on what it is you do, you might want to choose one diagram or the other. Now, as far as going for LED brightness, these circuit diagrams will achieve exactly the same thing. They will achieve LEDs, lights lighting up with equal brightness. That's not going to be a problem for either of those. The problem really is going to be wires. So questions are, what else are my circuit diagrams constrained by? Well, they're usually constrained by V forward, okay? So V forward of red, as we all know, is 1.8 volts. And V forward of yellow is 2 volts. As you can see, there is no way I can put more than 2 LED lights in the same branch, right? Because 1.8 plus 2 is going to be 3.8, and I have only 4.5 volts. If I add one more, I will definitely need more than 4.5 volts to light them up. So this is incidentally why your biggest power source should be a 9-volt battery, okay? Because I do not want you to make a circuit where all of your LEDs are in series. I want you to make a circuit where they're in parallel. But how many LEDs you're going to have in individual branch is really up to you. So this circuit over here, this is really a Christmas light circuit. So this is what you typically would see if you're making if you have Christmas lights. This is literally the circuit diagram for that. So generally, I would use this when you can wrap your lights around something. It definitely works really well like that. The examples I have in class from last year both use modified diagram that is very close to this. Okay? So, once you choose your circuit diagram, what do you do next? Well, you got to do your calculations. So what you need to find for your calculations is you need to find the value of your resistors. You need to know what is this resistor. You need to know what is this resistor, what is this resistor. Like, please notice that these branches are identical to each other in this diagram over here on the top. So I only need to solve this once. Over here, I have 2 different types of branches, one with red LEDs and one with yellow LEDs. So I would need to do that calculation twice. But once again, it's not a big deal. So how do you do this? How do you find this resistance over here? Well, the same way you did it in your power calculations assignment. So what you do is first you use your KVL. And in this particular case, it's going to be voltage of the battery equals voltage of the resistor plus voltage of the red LED and voltage of the yellow LED. And we know what those are, right? So this is 4.5 equals 2 plus V of R plus 2 plus 1.8. So when you calculate all of this out, you're going to get V of R equals 0.7 volts. Okay, so please keep in mind, this is not resistance yet, right? This is just the voltage, right? In order to find resistance, I need to know what is my current, because I need to use Ohm's law, right? I need to use V over I. So in order to use this formula, I need the current. But what is my current? Well, this is not a science class. You don't find the current, you assign the current. And what I want for my current to be, for example, I want in this branch for my current to be 10 milliamps. Can I do that? Oh, absolutely. Not a big deal, guys. So if I want the current of 10 milliamps in this branch over here, I can definitely do that. Now, which current can't I have? Well, I can't have anything over 20 milliamps, okay? You really, really don't want to do that because that will burn out your LEDs. So now that I have my current, I can definitely find my resistance. So all I have to do is R equals 0.7 over 0.01. And let's see what it is because I've been messing it up. So that came out to 70 ohms. So now I can go back into bill of materials and I can put 70 over here. What is my resistor, right? Okay, so now I've got my resistance. I need one more thing. I need to know my total current. Well, my I total is just the sum of the currents in my branches. So this is just I1 plus I2 plus I3. So in this case, it's going to be 30 because I'm going to make them 10 milliamps in every single branch. So there is one last calculation I need to do about this circuit, right? And that is how long will it take for my batteries to discharge? And to do that, I need to go online and look up a data sheet. So I'm just going to type in AA battery data sheet, and I'm going to pull it up, and I'm looking for this graph over here. So if I had just one battery, I would be somewhere over here on this chart. This one tells me the capacity, how many hours I'm going to have, and this one tells me how fast am I discharging my battery. But since I have a triple AA battery pack, and each single battery draws only one, right? It draws only 10 milliamps. So in reality, I'm somewhere over here. So now I can go back to my calculations and I can write down that my capacity is, battery capacity is between 3,000 and 4,000 milliamp hours, right? So that will come out to about 4 months of continuous work, okay? So this is really it. If you guys don't know how to do these calculations, review your power calculations assignment. This is very, very, very easy, okay? And review the video that I've made for the power calculations assignment. I'm going over all of that stuff in gory detail in that video as well. All right, guys, good luck, and remember that this is due, if you're in odd numbered period, in other words, 3rd, 5th, or 7th, it's due on Thursday. If you are in even numbered period, 2nd, 6th, or 8th, your written report is due on Friday this week. So please make sure you do it.